could let people into the rooms. So we've got, hi, I'm Julia from Surrey. I've been observing the moon since I got my first telescope at the age of 11, which is lovely. I remember looking at the moon with my dad when I was quite small, and he would tell me about his dad carrying him outside in a blanket to watch the Gemini missions launching because they could see them going across the sky from Wales. So I remember him telling me his story about the moon as my first memory of the moon. I'm going to share my screen. This is where it could go hideously wrong. I'm going to do advanced sharing options. I need to share sound as well. I'll do desktop, share sound. One of the slides does have narration on it because it's a NASA movie. I will say so before it plays, and if you don't hear sound, and only I can hear sound, one of you will need to tell me and I can re-go. We've also got Lexi, aged 11, viewing the moon through a telescope. Okay. Right. Can everyone see my screen before I hit present?
Yes.
Yes, perfect. Okay, so I've asked people to introduce themselves. So welcome to International Observe the Moon Night 2024. Those of you who don't know me, my name is Rachel Dutton. I'm an amateur astronomer based in Guildford, and I look after outreach at the Guildford Astronomical Society, as do my lovely co-hosts. I'm a fellow of the Royal Astronomical Society, and I have done some formal astronomy study, and I'm still doing that at the moment. And with me, if you can still see me on camera, is Space Snoopy, who was on the Artemis 1 mission, which we can talk about later if anyone's interested. Okay, so what we're going to cover, and I've noticed a mistake on the slide. We're going to cover what is International Observe the Moon Night, who we are and why we're talking about it, activities you can do at home, and most importantly, how to observe the moon as a beginner. So let's start off with just a little bit about International Observe the Moon Night. This is something that the International Astronomical Union and NASA have put together, and they have a ton of resources to help people get excited about astronomy. And the easiest target that we can all see is the moon. Astronomers hate the moon because it gets too bright and it drowns everything out, but it's actually a great target to get started with stargazing and astronomy. So, a fun game. There are 9 images here. I'm going to label them left to right, the top row, 1, 2, 3, 4, 5, 6, 7, 8, 9. One of these is a moon, not our moon, but a moon of another planet in the solar system. And this is really hard. And if you could put in the chat which one you think it is. I know some of you have seen this before and some of you haven't. And Julie, if you could read out people's guesses.
We have a unanimous guess here. So both Steve and A are guessing number 4.
Number
I'm
4.
not going to make a guess because I've seen it before and I know the answer.
Okay. Anyone else want to guess? No. Okay. So the correct moon is indeed number 4. This is Europa, one of the moons of Jupiter. It's going to be studied by the JUICE mission, which recently flew by Earth. The other ones, if you want to giggle, are actually the bottoms of saucepans in a NASA engineer's kitchen. But moons are minerals, as is metal that makes the bottom of saucepans. So enjoy. Okay, so let's get on to a bit of science. How did the moon form? There are 3 different ways you can make a moon. So the first way you can make a moon, we have a make it yourself moon as you make a planet. So here you've got a baby star, a protostar, with all this gas and dust around it, and it's swirling around. And eventually you'll see these bright areas are areas where material will collapse. You can see it here and here, and this will form protoplanets. And at the same time, you will get some of those protoplanets just don't have that much mass, so they will end up being a moon for one of the bigger planets. So that's a let's make it our self model. Now, if this was the case, the signs that our moon was made at the same time as the Earth would be that it would be made up of the same stuff because they're nearby in the bits of the cloud that they've come from. They would have the same stuff in similar ratios, and their axial tilts, I'm going to use Space Snoopy. If you imagine his helmet is a globe and you've got the axes going through it, that axial tilt would be the same for both the Earth and the moon, and it's not. So we can get rid of that theory. Our second theory is called asteroid capture. So hopefully you've all seen comets or asteroids in the sky and the beautiful pictures of neowise and things like that. Now, these are bits of rock and ice that have come from the outer solar system, and they come in towards the sun because of the gravity of the sun pulling them in. And sometimes they'll go past the planet. Jupiter is a nice big planet with a lot of gravity, and it'll suck that asteroid in with the gravity. And then that asteroid is captured and it's a new moon. Now, Jupiter has loads of these. Mars has 2, Phobos and Deimos, and you can tell because 1, they're made up of different stuff, 2 in different proportions, and 3, they don't look like nice, beautiful round globes like our moon. They look like these little rocky space potatoes, and Mars definitely has 2 little rocky space potatoes. And an exciting thing about Mars's moons is eventually they are going to get so close to Mars that its gravity will rip them apart and it'll turn them into rings. So those are our 2 theories. We have a third theory, and this is the one that we think matches the Earth. And there is a simulation I will move on to in a minute, and the simulation will play music. So what scientists now think has happened is that the proto-Earth, so early Earth, was hit by another planet, probably about the size of Mars, and that caused some of that material to come into space and form the moon. And last year, scientists published a paper finding the remnants of an old planet around the core of the Earth, which is pretty exciting. So let's have a look at that simulation. There will be music and it'll have words underneath, but no narration on this one. That was that one. That was pretty spectacular. We're going to move on to the second video that shows how the moon got its mare and craters. Could you guys hear the music on that one? Just nod. Yeah, so I'm assuming you'll hear the narration on this one, but wave at me if you don't. Let's see how we got the craters.
From year to year, the moon never seems to change. Craters and other formations appear to be permanent now, but the moon didn't always look like this. Thanks to NASA's Lunar Reconnaissance Orbiter, we now have a better look at some of the moon's history. The moon likely started its life as a giant ball of magma formed from the remains of an impact on Earth about 4.5 billion years ago. After the hot material collected into a sphere, the magma began to cool, eventually forming a crust on the surface of the moon with the magma just underneath. Around 4.3 billion years ago, a giant impact battered the moon's south pole, forming the South Pole Aitken Basin and sending debris as far as the opposite side of the moon. This impact marked the beginning of a period that would cause large-scale changes to the moon's surface. One by one, more huge collisions shaped the terrain, some forming large basins that would eventually fill in to become the dark-colored patches of the moon, known as maria. They began as normal craters, but soon started to change due to the size of the impact on the relatively thin crust. Because the moon had not yet fully cooled on the inside, lava began to seep out through the cracks caused by the impacts. The resulting volcanic activity spread lava throughout the craters, gradually filling them in and cooling. Because of the high iron content of the basalt in the rock, the maria reflect less light and therefore appear darker than the surrounding highlands of the moon. Around 1 billion years ago, volcanic activity ended on the near side of the moon as the last of the large impacts made their mark on the surface. The moon continued to be battered by other impactors, although they were much smaller than the objects that formed the largest basins. Some of the largest, most recent, and best-known impacts from this period include the Tycho, Copernicus, and Aristarchus craters, which are unique due to the complex system of rays that stretch out from the impact site. Finally, we arrive at the moon that we see today. Though the surface continues to be affected by impacts, the rate has slowed down drastically to the point where the moon appears unchanging to the human eye, as a permanent record of its own history, and a glimpse of how craters may have formed here on Earth.
So in case anyone didn't know, that was created by the NASA Goddard Space Flight Center. And I think that their animations are phenomenal and do a much better job than me waving my hands around, explaining things. Okay, so we're going to move on to observing the moon. I'm going to give you a few pointers and show you how to use binoculars, and then Steve is going to show us the moon. So let's talk about observing the moon. Important thing is safety first. It's really exciting to get into astronomy, but make sure you're somewhere safe as well as dark. So back garden is nice and safe, or we do observing events sometimes, or go out as a group somewhere and make sure it's somewhere that you've been at daytime so you don't trip over any hazards or anything you haven't seen before. Trying to get away from light pollution is important. However, the moon is super bright anyway, so it shouldn't be too much of a problem with the moon. Now, I'm going to give you a very quick 101 on how to use binoculars. So first of all, remove all the caps on them. And I've got lens caps here. Now, the common thing I see with people with binoculars, and we try and help them to use them, is that they grab up here somewhere and then they put them at their eyes, and that's upside down. And then they're trying to figure out the targets whilst they're zoomed in. So what you want to do is look at the target, so the moon, hold the very end of the binoculars, and then line up. I know I keep disappearing on the view. And then plop them there, and you should get the target very quickly. That's the easiest way to use binoculars. Now, these ones are my Celestron Skymaster 70 by 15s or 15 by 70s. And I've got a focus wheel in the middle and a zoom around the right eye cap make sure you read the instructions of your binoculars. These ones are very good. They're also very heavy. They're probably around 80 to 100 pounds now. So they do last a really long time in terms of astronomy equipment because they're nice and sturdy. So that's Celestron Skymasters 15x70s. They do have a tripod attachment. So if they're a bit heavy for little ones to use, you can plop them on a tripod, and that makes it a lot easier to use. But you can do a lot of observing with the naked eye. So first thing you can do when you're observing the moon is look at the different moon phases. So you can see the difference between the night side of the moon and the day side of the moon. Even on this slide here, you can see the day side that is lit up. And if you look shortly after dusk, you will see Earth shine on the dark side. So crescent moons are quite good fun for that if you look towards dusk. Now, they mentioned earlier the volcanic regions, the dark regions that became maria or lava beds. You can take a look at those. You can see them with the naked eye. You can also see Tycho crater, that big white crater at the bottom of the moon. If you had a circle with sort of spokes coming out of the middle of the moon, at our latitude, it's usually the spoke coming out sort of around 4 o'clock or 5 o'clock that Tycho is on that big white crater. And one of my favorite things to do when it's not a full moon is to look along the terminator, that line between day and night, because you can see the crater details of all the shadows and you can get a feel for the ruggedness of the moon terrains. So I'm going to ask Steve if you can give us a bit more of a tour of the moon. So please feel free to share your screen, Steve.
Let me share my screen 1 second.
Yep.
It's out of the way. Okay.
We can see your screen.
All right, thank you. I'll put this. So this is actually a video on the right side here of the moon, which I took last night just on the playing fields at Guildford Park with my son. So it'd be as close as we could to this evening because I knew it'd still be a little bit light and the moon's very low at the moment. So you can see it shaking every now and again. So the shaking you see is the atmosphere of the because it's quite low. The atmosphere, the air in between us is moving all the time. So you see kind of the like a shimmering of the image.
I've heard astronomy described with the atmosphere as doing bird watching from the bottom of a pond, and the pond being like the atmosphere.
It's quite tricky and it's very low at the moment. So I made this still image from the video, and I thought we could. So this on the left side here is on the NASA. NASA's moon map that's on their website for the moon. So as was mentioned before, you can see the different Mare Imbrium here, Mare Serenitatis here, Tranquillatis, and Chrysium. So you can see each one of these. And Nectaris, Fecundi. I'm not very good at my Latin pronunciation, so forgive me. And then you can see the Copernicus crater, which was mentioned in the video. That's this one here. And then Tycho, which is another famous one down here. If you look carefully, you can see these lines, and it was mentioned briefly on the video. And you can see here, like radiating out from where the impact craters are. And these are called ray systems. So they're bright ray systems of the from after the impact. And then you've got on the edges of some of the craters that filled in with the lava, you've got what they call mountains. So this one here is they're called the Apennine Mountains. It's not actually showing the name of this one, and I forget.
That's Sinus Irid in the Bay of Rainbows.
Yeah, and then you've got there's Jura, isn't there? The Jura one.
Yes.
No, I think it's the Jura, this one, or this one. I can't remember which is which now. But yeah, I think that's the Jura there. You can see here. So yeah, you've got the mountains on the moon, and then there's some. So that's craters, and the mare, and then the ray systems, and there's some other things that are a bit more unusual that you can see. So these ones were taken by my daughter, but with a more professional telescope. So you can see this faint line here. This is a rill, and Hyginus, or Hyginus, I don't know how you pronounce that, but this is like a crease or a canyon in the surface of the moon. There's not many of them. That's the brightest one you can see with a more smaller telescope.
And
then
those are the remnants of the collapsed lava tubes, aren't they?
that's what I understand. Yeah,
Yep.
yeah. No, thanks for that. And then you've got these lunar swirls, and this is the brightest one. It's just here. So this is the Renia Gamma, and nobody really knows how these lunar swirls formed. I think it's something to do with magnetism.
Yeah,
As
that's the
it's
latest
falling back
theory.
down, but there's not really a proven way on how they'd formed. Put the video back. So yeah, this is from last night, as I mentioned.
I love the detail you can see on Tycho crater there, and you can see all the
Yeah.
other craters. And the reason why there are so many expeditions at the moment going to the South Pole of the moon is because some of those craters are permanently in shadow, and there's a possibility that there's water in them in there somewhere. And you need water, obviously, for life, but it can be used as fuel for future space missions, and it can be used to help create artificial atmospheres. So that's why everyone's super excited about that region that Steve just zoomed in on. Could you take us to just the Terminator again so we can look at the crater detail? Because you can see there that that sharp shadow, you can just about make out, it looks more 3D than during a full moon where everything just kind of looks flat because it's washed out with light.
Yeah. The way you can see the light on the mountains here.
That's incredible. I think I could spend hours studying this image with you and would still find lots of really exciting bits to point out.
Put the video back on.
You can play the video one more time. There it is.
This is more like how you would see it through a telescope, just shaking very slightly every now and again. Yeah.
Yes. Beautiful. That honestly looks like a live feed if I didn't know better.
Yes, this is taken with the C-Star S50 telescope and just recorded on my phone.
I can actually dig out my sea star very quickly because I do have it next to me. I'll show it in a second. Oops. Okay. Right. Thank you so much, Steve. That was really good. Awesome. So just in case anyone's wondering what he's talking about, this is the sea star, and it comes with a little baby tripod, and this is a really good, cheap, low-end telescope. But as you can see, it does a lot. We use it for deep sky things as well, and I say it's cheap. It's about £500, but compared to a lot of predecessors out there that you get the same resolution, that is a bargain compared to some of the rigs that people have. So I'm just going to put that back down in its padded case. So that's the Sea Star. They should put me on commission. I think I've sold quite a few of those. Okay, I'm going to go back to sharing my screen. So thank you so much, Steve.
Okay. No,
I hope
thanks.
people enjoyed that. So let's continue. We've just had our lunar tour. So let's talk about some things that you can do to explore the moon, both with the moon out and at home with your friends, with your family, for all age groups. So first of all, you can look at the stories and the myths of the moon. So each culture around the world had a different origin story for the moon. So we're going to do a little quiz, and you can put in the chat what country you think each myth comes from. So the first one, I need to move this down so I can read it. Arianrhod was responsible for the souls of warriors who had fell in battle. She gathered them aboard her ship, the Orwheel, and transported them to Emania, also known as Moonland. In the northern sky, whirling around the enduring stability of the North Star, Arianrhod presided over the fates of departed souls, nurturing their journeys. I can't quite read the end, unfortunately, because their journeys between lives. So the name, I think, is a bit of a giveaway. Does anyone want to guess what country that myth is from relating to the moon? Julia, do we have any guess?
It's not Australia because it mentions the northern skies.
Yes.
I'd give it a guess as maybe Wales.
Has anyone guessed in the chat?
No, no one's guessed in the chat yet.
Your guess was perfect. Congratulations. So let's carry on. Okay. Sorry, I've got problems with bits of Zoom getting in the way of the bottom of the screen. Okay. Khonsu was a god of the moon and time. He was one of the companions of Thoth, who was also associated with the moon and the measurement of time. And also involved in the creation of the universe, he was also revered as a god of healing, was said to heal Ptolemy IV, and also thought to extend his protection to the common people. What country do we think this myth has come from?
I think I know this one.
Feel free to type in the chat and Julia can read out to us. And anyone else, feel free to type your guesses in the chat. There's no bad guesses. So Julia, what guesses do we have? Do we have any in there?
2 people have said Egypt.
Amazing. Ancient Egypt. You are correct. Okay, the final one. Ishel is one of a number of moon goddesses herself, associated also with fertility. She was an old woman who carried a jug of water around with her. Every so often, she would overturn the jug and send powerful floods and rainstorms to the earth. Now, I will say, think rainstorms and rainforests as a clue with this one. It's a lot harder.
No guesses yet.
No, it's a different continent.
Ah.
And if you think ancient Egypt is famous for pyramids, this continent is also famous for having pyramids of a slightly different shape.
2 people have guessed Brazil.
Oh, I am impressed. It's the Maya people. Well done. Well done indeed. Okay. So that gives you a flavor for some of the different stories that are out there. There is a campaign called Everyone's Moon, and it looks at the different stories around the world. We've also got some really interesting history that you can explore with the moon. So we've got the Apollo missions, which has some very incredible stories and unfortunate tragedies in terms of mankind's first race to the moon. So that's something that can be very interesting to research. We have, obviously, everyone knows Neil Armstrong was the first man on the moon, but there were several missions to the moon. We also had Apollo 13, which is an incredible story of survival and how they got back again. We also have the Artemis missions, which finally, moon missions named after a goddess of the moon rather than the god of the sun. And we've had the first Artemis mission. On Artemis 1, there was Space Snoopy, who I have with me. We also had Shaun the Sheep on there. And there were also 2 phantoms, which are 2 dummies with lots of radiation sensors on there. And one of the teams I'm in is looking at the radiation sensors. So we can look at the different things that are going on with the moon. And then we also have the NRHO gateway, which is the Near Rectilinear Halo Orbit Gateway, otherwise known as International Space Station Mark II. And this is going to go around the moon. And the return trip and journey out will be 7 days each way. So that's going to be quite phenomenal. So those are things that you can research about the moon, and they can be quite good fun. Now, we've also got each crater was named after a different scientist, and this can be quite good fun to do. So, for example, Steve showed us Tycho crater earlier. Tycho crater is named after Tycho Brahe, who was a Danish astronomer who created a lot of important things in astronomy, but he was also quite the character. So we don't know if he was taken from his parents or sold off to a rich family. He got into a boasting competition at university as to whether he or someone else was better at maths. And then they decided the best way to resolve this, instead of having a maths off, they decided to fight each other with swords, and he lost part of his nose. So that is quite interesting because you've got someone with a brass nose. He also had a pet canoe and lived in a castle. So each scientist has something spectacular about them. Only 32 out of 9,137 are named after women, which I'm a bit upset about. Women especially have contributed to astronomy, but not been credited for it throughout, not just the centuries, but the millennia. The first astronomer we know of is also the first author, who was Enheduanna. So you can really sort of dig into those stories there. It's always good fun to grab a lunar map and read the crater names and then find out more about the scientists. So you can find out which scientists were metaphorically thrown into the Sea of Storms to appease the Vatican Church, because obviously heliocentrism, where we say the sun is the center of the solar system, was a bit political back then. One of my favorite craters is named after a scientist who also has a breed of penguin named after him. So you can have really good fun with these. Okay. And you can also look at different religions and cultures that involve the lunar calendar even now. So you've got the Chinese New Year is based on the lunar calendar. Ramadan is based on the lunar calendar. You've got full moon parties in Thailand, and the calculation dates for Christians for things like Easter is something like the Sunday after the first full moon after the spring equinox. So you can look into how different cultures use the moon in different ways, even now. There are science-based activities you can do. So there are some really interesting questions that you can search for. YouTube has lots of videos for people of all ages on these. So how does the moon create tides on Earth is a good one. The moon's role in lunar and solar eclipses. What's a supermoon? Spoiler alert, it does not involve the moon wearing a cape. What moon phases have to do with the times of moonrise, moonset, and the tides? What are the theories of how the Earth was formed? That can be very interesting. And what causes moonquakes? Because on Earth, earthquakes are due to tectonic plates. And as we saw earlier, the moon is no longer volcanically active. So how does it still have moonquakes? You can become a citizen scientist. There are lots of different projects available, so you can hop onto the NASA website or the Zooniverse platform and join one of these and contribute to science, and you may even get your name mentioned in a scientific paper. You could also be the first person to see some of these images ever, which is pretty exciting. So what is citizen science? Well, it used to be that if you wanted to get research done, you would grab a PhD student and ask them to analyze lots of different photographic plates. And they would spend 3 years doing this, and potentially then they might be able to have processed enough of that data themselves for you to be able to do science with it. However, this is really slow and inefficient. So citizens can go and do some of those basic classifications themselves. And the Moon Disk project actually shows lunar craters imaged at one point in time and then imaged at another point in time. And you can say whether it's changed. And that gives us an idea whether there's been a crater caused by another asteroid smashing into the moon. And there's lots of different projects in there that you can get involved with. And they are not just astronomy related. You can go in and count the number of penguins in a picture. So they're suitable for lots of different ages. There's also lots of different art and craft activities you can do. You can 3D print or paper mache a lunar surface, which can be quite fun. You can draw the lunar disk, draw the lunar craters. You can do moon-inspired art. You have the Lunar Reconnaissance Orbiter mission photos for reference. So you can go onto the LRO website and find them. You can go to the Guildford Astronomical Society gallery page and find not just images that our members have taken, but also drawings of the moon. Some of them are mine, that you can go in and take a look at and get inspired, and feel free to send us your images too so we can see them. So actually, before I tell you a bit about gas, Julia, you wanted to talk a bit about 100 hours of astronomy.
Yes, I just wanted to mention it. So it's an initiative by the International Astronomical Union that you mentioned at the beginning. And every year they do an event called 100 Hours of Astronomy. And in the UK, it's taking place between the 2nd and 5th of October. And this year, for the first time, they're trying an online activity. I'm just about to put the link in the chat, but basically you can download the app or go to their website and grab a marker, and then you're set up with 4 very simple challenges. And these are to identify a planet in the sky and to look at some constellations. And as you find each one, you get a little pin on the map, which is great fun. And you can share your findings on social media with your friends. So this is aimed at everybody. It's really good for beginners, and it sounds like a lot of fun. I've previewed it and it's great. So get involved in that. It's free to do. You don't even have to go outside and get cold.
That sounds like really good fun. I think I'll be signing up for that as well. So that sounds like good fun. Okay, I'm going to offer this as time for people to ask questions about the moon, if anyone's got any. And then I will quickly talk about Guildford Astronomical Society very briefly. Nope, there's no questions. I'll just quickly share my screen again. There we go, so screen share. Okay, so we do public events, so keep an eye on our mailing list. I do have to say they are weather dependent though. So for example, tonight we suddenly had a forecast of clouds, which looking out at the sky actually appears to be wrong, but it's a bit challenging to convince people to turn up when there is a forecast of clouds. So sometimes we'll switch to Zoom. But also, if you do want to look through other people's telescopes on a regular basis, we do have our own visual astronomy group where we join each other for observing. I know everyone who, all my co-hosts on the call have turned up. We get to look through some very nice telescopes that different members have. So it's a membership-based society, so it's not for profit. We have the visual observing group. We meet up once a month. We also have an astrophotography group where we take lovely images of the moon and other targets like planets, deep sky objects such as different nebulas. We also have an exoplanet hunting group. And we do also have society telescopes for members to use. So if you're interested, do go to the Guildford Astronomical Society website, and I'll just see if there are any final questions at all in the chat before we finish up. Okay, I think there's no questions. But if you do have any, feel free to email outreach@guildfordas.org. And I'm going to stop the recording there.